Our galaxy has billions of habitable planets, yet space is silent. That mismatch is the Fermi paradox, and it's a serious puzzle. The paradox forces us to question our assumptions about life in the cosmos. So the puzzle is simple and deeply unsettling. In 1950, Enrico Fermi blurted out a single question. He asked, "Where is everybody?" referring to extraterrestrials nearby. Put plainly, many habitable places exist, but no obvious visitors. That contrast is the paradox, and it matters deeply. One mechanism behind it is sampling bias and time scales. Civilizations may rise and fall in brief cosmic instants. We might be looking at the wrong place and wrong time. An example is radio leakage from Earth, which fades quickly. It forces us to rethink search methods and assumptions. Net result, many possible homes and still no clear contact. The Drake equation multiplies factors to estimate alien civilizations. It names terms like star formation, planet fraction, and biology. Each term is an uncertain number, and errors multiply fast. That means a few small changes alter the final result dramatically. For example, if 1% of planets host life, numbers swell. But if life is rarer, like 1 in a million, numbers collapse. So the equation frames possibilities without giving a single answer. An actual estimate once suggested thousands of civilizations, another suggested none. Thus the Drake equation shows massive uncertainty, not certainty. Even a civilization can be invisible if its signals don't reach us. Signals weaken with distance, and cosmic noise hides weak emissions. Also, technologies change, and old signals may be short-lived. A powerful transmitter fades to background within a few hundred light years. Quick mental image, a lighthouse whose beam thins across an ocean. If civilizations broadcast briefly, the chance of overlap is tiny. We also worry about different physics and unknown signal types. Example, Earth's radio leakage peaked mid-20th century, then declined. Searches tuned only to radio might miss infrared or neutrino signatures. So detectability limits mean silence may hide many unseen civilizations. One solution is the Great Filter, a barrier to life or intelligence. If the filter lies behind us, we beat the odds early. If it lies ahead, most civilizations never make it to longevity. Filters include rare evolutionary steps or fragile planetary conditions. For instance, complex life took billions of years on Earth. That long wait suggests complex life is not inevitable elsewhere. A numerical example. Suppose complex life appears on 1 in 1,000 planets. Then intelligent civilizations would be separated by enormous distances and time. So the Great Filter could explain emptiness, either past or future. Civilizations may simply self-destruct, cutting their own signal short. Weapons, ecological collapse, or runaway AI could end a civilization quickly. That creates a brief window for detection, and timing becomes critical. An example, human high-tech civilization spans only a century so far. If most civs last centuries, overlaps across light years remain unlikely. Alternatively, advanced civs may switch to low-leakage tech, hiding their presence. Example, fiber optics and directed beams reduce waste radio emissions. In short, self-destruction and quiet technology both shrink detection chances. Some propose deliberate silence, like a cosmic zoo policy. Advanced beings might observe without interfering to preserve development. One possible mechanism is non-interference rules, hidden probes, and private channels. If so, signals are intentionally disguised or routed away from us. Example, probes in the solar system could monitor Earth silently. Other ideas include post-biological civs that compute privately, not broadcast. These scenarios change the assumptions behind our searches dramatically. So intentional secrecy and different priorities could explain apparent emptiness. The silence has pushed scientists to try new detection methods. Instead of radio, searches look for technosignatures like waste heat. Infrared surveys hunt Dyson-like structures by spotting excess thermal emission. Neutrino and gravitational wave astronomy open fresh, low-noise channels. These methods search for energy misuse, not intentional messages. Example, astronomers scanned hundreds of thousands of stars for infrared excess. So far, no definitive technosignature has been confirmed. Thus, improved searches expand our net, but silence persists. We still live in a galaxy full of planets, and yet silence remains. If you found this interesting, consider subscribing for more cosmic puzzles.